This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Support for this episode comes from SingleStore. Scaling modern SaaS is hard. It's even harder when you're using databases that were built the last time boy bands and low-rise jeans were all the rage. SingleStore is a modern cloud database built for today's data-intensive applications and the smart SaaS generation. SingleStore powers the new wave of SaaS technologies, displacing legacy providers. Use it to break the data bottleneck and reduce your monthly cloud bill in the process. Learn how SingleStore can help you at singlestore.com/SERadio.
Hello everyone, this is your host Kanchan Shringi. Welcome to Software Engineering Radio. Today our guest is Venky Naganathan. Venky is Senior Director of Engineering at Conga. He specializes in artificial intelligence and chatbots. In the last 2 years, Venky has led the Aptus, now Conga, Max AI mobile assistant for quotes and contracts, from a cool new lab concept to a live product. Max is a Siri, Google Assistant, and Alexa-like AI-powered intelligence platform that acts as a personal assistant for sales and marketing personnel. Prior to Conga, Venky was Director of Engineering, AI Platform Services at 247.ai. Welcome, Venky. Really looking forward to our conversation today. Is there anything else you'd like to add to your bio?
No, that looks great. I'm looking forward to our chat. Thank you.
Let's jump in with a very basic question. What was the need for this new conversational AI for your B2B app, and why now?
So I think of traditional user interfaces as something that's more suitable for use cases that we can anticipate in advance. For example, if you're building a banking website, your traditional user interface is good for users logging in and retrieving your basic account information and transaction history. But I'm sure your application is capable of delivering, a far more diverse set of information at much greater depth. For instance, if the user has questions like, what's my average daily balance? How many ATM transactions have performed in the last month? Unless the user interface has these options, there's no way for the user to retrieve this information. Chatbots help collapse the complexity of your user interfaces and deliver far more information using a much simpler UX. So that's essentially how I view chatbots and virtual assistants for most applications. And also, if you look at it from a historical perspective, virtual assistant is basically a natural evolution of user interfaces. At one point, we used to live on command line interfaces, and then they became GUIs, and then they got subsumed into the web interface, and then soon it was on mobile. And nowadays, applications are becoming more complex, so users are becoming more demanding. So to address all of the use cases and deliver an optimal UX, we got to mix traditional user interfaces with non-traditional ones like NL. So that's where it fits in.
So why is it taking off now, though? Was this need not felt earlier, or is it just that we have the technology at this time?
Yeah, the rise of Siri, Alexa, Google Assistant like platforms have popularized this, right? A lot of users are beginning to use it, and they consider it useful. And also the technology has evolved to a point where building such technology, such interfaces in a credible manner is possible now.
Tell us a little bit more about Max. You certainly alluded to the fact that the technological evolution helped that, and there was a business need too, but maybe you can tell us a little bit more about the business aspects as well.
Yeah. So first of all, Max is, like you said, it's a Siri, Alexa, Google Assistant like virtual assistant. It's capable of workflow automation, skill automation, and also it's capable of many other things which I'll talk about as we go on. There are a couple of reasons why we really built Max. First is the business need, and second is we also saw an interesting industry trend. So on the business need, before I talk about it, I need to give you a little bit more context about what we do at Conga. At Conga, we build software applications that help our customers run their revenue operations. Our typical end user is an enterprise salesperson they're not the only persona, but they are the typical persona for our products. And the typical use case is a salesperson taking a pre-sales opportunity all the way through sales demo and quotation process to turning that into a contract, and managing the redlining process and turning and getting that signed, and managing the life cycle of contracts, turning all of that into cash, etc. So this is the code to cash domain, and workflows in this domain tend to be really complex. So we needed a tool or an engine that can simplify user experience and improve productivity in this domain, right? So that's the genesis of Max. And second, on the industry trend, not too long ago when Steve Jobs introduced the iPhone, probably about a decade and a half or so ago, BlackBerry used to be the dominant brand in the enterprise, right? Today, you don't see BlackBerries. It has been completely replaced by smartphones. Similarly, once upon a time, we used to make phone calls to our colleagues to collaborate. Today, we use messaging, right? So these are all examples of strong consumer trends pushing an incumbent trend out, and making their way into the enterprise. So we see a similar thing happening with chatbots, right? So the advent of Siri, Alexa, Google Assistant, like you said, have improved user experience in the world of in the consumer world, and we think that it's just a matter of time before they find their way into the enterprise. So it's still very early stages, but it's going to happen. So those are really the drivers for Max.
Can we take an example of a question that Max is asked and then talk about what distinguishes Max from the others?
Yeah, so you can ask Max to automate a workflow or create a workflow. For example, you can tell Max to create an NDA for Google and send it to Kanchan for signature. So Max will automatically figure out all of the details involved in orchestrating the workflow and accomplish that. It's like your virtual secretary. Or you can tell Max to pull up information that satisfies a particular criteria, right? For instance, you can tell Max to look up all the MSAs that are over $20,000 from last year that are set to expire this quarter. And Max will understand the nuances in the sentence and pull up the exact information. Max is also capable of providing you just-in-time notification of important events that happen in the system. It behaves exactly like a very intelligent human secretary, right? Constantly reminding their bosses of what needs to be done, and also helping their bosses, be productive. In terms of differences between Max and the conventional bots that you see out there, so first, let me talk about Google Assistant, Alexa, and Siri. They are more encyclopedic in nature. They go, a lot broader. They try to address all possible questions, but they are a little shallow, right? You can ask them things like, how is the weather in San Francisco? Or when is the Thanksgiving next year? Typically, they answer one or two questions, and that's the scope of those assistants. You can still go deeper. You can build vertical skills with Alexa, for instance. If you do that, you will end up creating an application like Max. Right? Max is more comparable to the assistants that you see on travel websites and retail websites and so on. It's purpose-built for a particular domain to serve use cases in that domain well, right? One of the things that we did before we built Max is, did an exhaustive research of what's out there to understand how to build Max. And what we found is majority of the bots in these travel websites and retail websites, they overpromise and underdeliver. They're usually very rigid and rugged. What that means is they're just chatbot-like interfaces, but they behave like traditional menus, right? You pretty much have to do what they expect you to do. If you veer off course, then you're going to end up with a suboptimal user experience, and typically users notice that quickly and disengage right away, which is why these bots don't work. So Max is built like Google Maps. So what that means is it helps the user and guides the user and stays with the user and helps the user get to where they want. But if the user veers off course, it stays with the user and still continues to help the user, right? And as I talk a little bit about the nuances of how to what goes into this and how to build this, you will understand the capabilities that we have thought about and developed.
So will Max coexist with your web and mobile UX, or over time do you expect it to take over more and more of that?
I see that as a supplementary interface to what exists, right? You cannot, chatbots won't work out because they're exciting. This is a common misconception that people have. Oh, I built this cool new thing, everybody is going to start using it, and so on. First of all, you have to think of them as a tool to improve productivity in specific contexts, right? And also, for them to be successful, they have to do skill automation. It cannot just be that it saved 14 clicks. That's not why people use a tool, right? So, more generally speaking, if you rewind to maybe 15 years ago, 20 years ago, when you call an airline, you would have heard, oh, welcome to XYZ airline, press 1 for English, 2 for Spanish. And then when you pressed 1, you heard 1 for flight status, 2 for reservations, etc. There were these hierarchy of menus, and then each menu had nested menus, and then it led to more nested menus. And the complexity of the UI was just through the roof. And if you make a single mistake, you're probably going to start all over again, right? It made for a really frustrating user experience. So think about how the same menus are delivered today, right? Today, it asks you, what do you want, right? If you want to check for flight status, it pretty much takes you there right away, right? So that's a classic example of how people have used virtual assistants to simplify the user experience. And in the case of Max, I talked about creating an NDA and sending it to somebody for signature. There is a little bit of skill involved in creating an NDA. You need to choose the right templates and document format, and you need to understand a little bit of legal, and also you need to know your company processes to send it to somebody for signature and get it all done. So here there is an opportunity for us to do skill automation, right? So by just giving a simple command, you have a tool that behaves like a secretary and accomplishes exactly what you want. And in addition, you can think of these virtual assistants as something that can help you access information on the go. If you're on your mobile in an airport, you can access information quickly. You can get reminder notifications and take follow-up actions on them, etc. So these are all the different scenarios where we think these bots or virtual assistants will be useful. I don't think of them as interfaces that can completely replace the traditional interfaces that are out there, because traditional interfaces are still very valuable. If you're doing something really lengthy and tedious, think about creating a code with 10,000 line items. There's no way you're going to do that effectively with a bot, right? You'd much rather have a Excel spreadsheet like tool where you have complete visibility and control of everything that you want, and it gives you the flexibility to go and tweak anything you want. So the traditional interfaces are still going to be there, and I see bots and virtual assistants as an opportunity to supplement those user interfaces in a targeted manner and make it a lot more useful and productive for the end users.
So my takeaway from what we've talked so far is that this new assistant is purpose-built. It has to be conversational, really conversational, not rule-based, and capable of deep conversation, handling follow-up questions. Given that, can we now discuss what does it take to build an assistant like this?
Absolutely. I think there are 4 major pieces that go into building a virtual assistant, a really good virtual assistant. So let me talk through them a bit. First is the user interface. The second one is the NLU engine with all of the capabilities that you need to build a sophisticated virtual assistant. And then the third piece is the dialogue orchestrator. You can think of it like your little operating system for running your bot application. And then finally, your actual bot application that runs through your use cases or workflows, right? So let's start with the user interface. So you need to think about where do you place the bot? How do you surface the bot, right? Typically, bots don't exist in vacuum. It's very rare for a bot to be the only application that delivers all of the user experiences that you want to deliver. Typically, they coexist as part of a larger ecosystem. So typically, people put these virtual assistants on their websites. It's pretty straightforward interface. You just have a way to launch your bot application on your website, and then you can engage with the user using either voice or text. Typically, it's text. Or you can surface your bot application as part of your IVRs, right? Like you've seen with all the airline companies. You may already have an IVR, in which case you just attach your bot to that IVR. You build a little IVR app and attach it to your existing system. Or you could consider placing a bot in social channels. If you already have an existing channel on Facebook Messenger or WhatsApp or one of these social channels, you could consider placing a bot there as part of that ecosystem. Or you could consider placing this in a mobile app if you already have one, right? In the absence of any of these alternatives, you want to think about surfacing the bot or meeting the user where the user already lives, as opposed to dragging the user to your own app, right? This is a classic. A lot of people think, oh, I need to build a mobile app to deliver this, right? So what you want to think about is, if you take I have an iPhone 12 and I have 24 apps on my home screen, right? And how many of them do I really launch on a daily basis? Maybe one or two. And then there are 3 or 4 pages of these apps. I very rarely or never launch an app on the 3rd or 4th page, right? So if you're going to pour in a lot of R&D dollars to build an application, you make sure that it is going to be useful for an end user and they're going to use it on a daily basis. Right? Otherwise, you may consider placing your bot in existing channels. So we build for users who live in the enterprise and they already use tools like Slack and Teams. So we thought it is more appropriate for this to be, our Macs to live in those ecosystems, right? So Macs can be accessed via Slack and Teams. So that makes it easier for us to, solve, user adoption problems and so on. And it reduces the friction. So that's the first decision you need to make, right? And once you've decided where you want to surface it, you build the appropriate UI integrations and build the appropriate UI widgets to surface your output or as well as solicit the input. Then comes the NLU capabilities. So here, typically, you will have to make a buy or a build decision. So unless you're trying to distinguish your technology on NL itself, which is pretty rare, or you are operating at such mind-numbing scale that the economics wouldn't work out for you, you probably want to consider buying this technology. There are a lot of good ones out there.
So NLU meaning natural language understanding. And as you're talking, maybe you can also distinguish that from NLP or natural language processing.
Sure. So let me talk through the components and then we'll talk about NLP, NLU, ML, etc. then maybe. So I was talking about the potential buy versus build in NLU, and I was recommending more buy because there are pretty good technologies out there. There is Microsoft Lewis, IBM Watson, Google Dialogflow, and then many more that you can consider. So NLU helps you take user inputs, process them, understand the semantics of what is being spoken, so you know what to process or how to process it. Right. In addition to the NLU engine that I suggested buying, you probably need to augment that with your own, domain-specific NL handling. For example, in the case of Macs, we had to build a stack of NL technologies and parsers that understood business speak, currencies, timelines. So our users can say things like pull up codes that are set the end date of this code to first workday of the third quarter of FY 2021. This is a complex timeline expression, right? In order for us to process this correctly, we need to translate these types of expressions to accurate dates. So in addition to the generic NL handling that understands the semantics, you also need to solve these vertical or domain-specific NL expressions. So you typically will end up building on top of the NL engine that you use. So that's the NLP. So once you've received the input, processed the input, understood the semantics, processed all of these complex business speaks, now you have all of the information organized to process this and take it to the next step. And then comes your application level processing, right? Here you need to think about, do you need to build any further infrastructure in order for you to process this? For example, we had to solve this natural language to SQL translation problem for us to accurately take the information that the user spoke to the actual queries that can be run on the database and the appropriate results produced. So that's again a part of your NL ecosystem that you need to build, right? Okay, so that's the NL part. The third is the dialogue orchestrator. So I would describe this as a mini operating system like capability to host your bot application, right? So once you understand what the user said, you need to hand it over to a bot, right? You need to initialize the bot. You need to provide the space for the bot to execute, another container type infrastructure to execute. You need to initialize the state of the bot. And then as the bot executes step by step, you need to stay with the bot, help the bot execute all of these steps. And then when the bot produces an output, you need to hand it back to the user interface. And then you need to swap the bot out and persist all of its state, right? And multiple bots could exist in this ecosystem potentially, right? So that's what this dialogue orchestrator does. Now, is this a buy or a build? Well, if you are building a one-off bot, one or two bots, you can consider purchasing this capability as part of the core NLU engine itself, because some of the NL vendors try to solve this for you. But usually they're very limited. But if you're building something generic and you're going to build hundreds of bots, then you may want to consider building your own dialogue orchestrator, because that gives you a lot of flexibility. And then finally, you have your bot application. Now, the bot application is the one that actually understands the user input and executes the use case and produces results, right? So here, there are a lot of best practice considerations that you may want to think about. First is, when a bot is launched, you probably need to offer the user some kind of a menu or a customer welcome screen that invites the user to engage in productive conversations. It helps the user understand what are the possibilities. And then as the user moves along, you want to offer the user proactive tips, right? So if the user pulls up accounts, you want to tell the user what they can do with these accounts. Because unlike traditional user interfaces, it's not very intuitive what the bots can do, right? And bots can potentially have infinite capabilities. How does the user discover these capabilities? So you need to help the user understand this wherever possible without being too invasive. And you also want to offer users help that is context sensitive. So if the user is viewing some information, the user is looking at the payment options and asking for help, you want to offer help related to payment options. And also, the other thing that is important to consider is topic switches. So as humans, we tend to switch topics, right? That's how we think. If you're asked a question, you typically answer a counter question in order for you to uncover the answer to the previous question. That is how we think. Bots do not understand it. If the bots are rigid and they don't allow the user to ask these questions, they'll be pretty limited and not very useful. So it's kind of like a little subroutine call from your main routine if you're a programmer, right? Allow the user to do the topic switch, go explore this new world, and then help them come back. Navigation controls is the other consideration. So this is a constant source of frustration for users. Bots often take the user down a path and then box the user into that little space, and the user cannot come out of it. This makes for a really frustrating user experience. User may have, by mistake, gone there because the user doesn't know what exists there, but you need to allow the user to come back. Right? Go back to the step 3, go back to the previous step. Let's get back to payments, right? So users should have the ability to navigate the bot from wherever it is. And bonus points for handling graceful endings. So usually users say thank you, and then it's good to say you're welcome, as opposed to meeting that with silence. And then sometimes users don't necessarily ask the questions that you are anticipating, right? Users may have a related question, but still a relevant question, right? If I'm going to a Best Buy, website, and the bot, let's say, can handle questions about TVs and DVRs, I may have a question about the store location, right? Where is the nearest store next to my home, right? And if the bot cannot answer that, then it doesn't help me. So being able to handle related questions that are still like valid questions goes a long way in establishing that trust and credibility with the user. And the other capabilities that we should consider building are some sort of mechanism for the user to provide feedback, because you don't want to assume that your bot works perfectly and produces good results. That's one of the challenges. When a user asks something, you produce something, you don't know in software whether you produce the right output or not. It's the user who's going to judge that, and give the user an opportunity to provide feedback and listen to this feedback and learn. Handle chatbot lingos if you can, because these days terms like BRB and TTL kind of phrases are pretty common. That's what users use in other chat tools, and they tend to do the same thing with your bot. So understand those things. Handle profanity. Unfortunately, no matter how good your bot is, sometimes it can make for a frustrating user experience, and this can usually cause users to swear at the bot. So be prepared to handle that. And use analytics to track the usage of your bot, track the performance of your bot, and then pay attention to this data, and then keep refining your bot. So these are basically the characteristics of a bot application. So overall, to summarize, you need to think about where to place your bot in the user interface and how best to deliver this. And then second, you need to think about the NL capabilities that you want to have. Then you need to think about a dialogue orchestrator. And then finally, you want to think about the actual details of the bot application itself. So those are the pieces that go into building a really good and powerful bot that makes the end user productive.
So a couple of follow-up questions on that. You mentioned there could be hundreds of bots, at least several. So what is the scope of a bot typically in this context? And I assume, certainly there are multiple conversations going on, so there must be some work to manage the state across these as well. So can you just comment on these two things?
Yeah. So if you're a B2B vendor and building bots for multiple businesses, each bot could be a bot that serves a different, tenant. Or even within the same tenant, you can have a payment journey, you can have a FAQ journey, you can have a account access and cancellation, you can have, if you're in an airline business, it could be a flight status bot, it could be a reservations bot, it could be a mileage account access bot, and so on. So these bots could be totally independent, or they could play with each other. So all of those are possibilities, right? So how these bots actually interact with each other, the details of that is within the bot applications. But Dialogue Orchestrator will offer that infrastructural piece for you to build these bots that can interplay with each other more effectively.
Thanks for that, Venky. Let's now drill deep into NLP, NLU, and also where machine learning and deep learning would fit here.
Absolutely. So all of them are kind of related. So I think of this as, think of artificial intelligence as a superset, and then machine learning is a part of that. And NLP and NLU is part of machine learning, and so is deep learning, right? So let's talk about them one at a time. So NLP and NLU are close cousins, right? You can think of that as overlapping subset, or you can think of that as one within the other. So NLP is basically a set of techniques to take user input, process it, prepare it for next steps. So when you say, I'm running 100 meters in the Olympics, there are a lot of words in that sentence. I am running 100 meters in the Olympics. So NLP tries to tokenize your input and split it into tokens. Then it does stop word removal to remove unnecessary words. It does something called, root word identification by doing something called stemming and lemmatization. So in the case of running is not as interesting as the word run. Run is really the root word. So it does all of this preparation to ensure that the subsequent steps can be more easily performed. So that's essentially what NLP tries to do, right? NLU is understanding the semantics of these utterances, right? What is the user really trying to say? What is the intent behind the statement? For example, when the user says, pull up contracts over 20K from last year that are set to expire next year, users simply wanted to, look up the contracts or agreement records. That is the intent. And there are several parameters to this intent. 20K, over 20K, from last year, expire next year. These are various parameters for this sentence. So NLU tries to understand the parameters for the intent. And then in some cases, you probably want to understand the sentiment and so on. In other cases, it may be more. So this is essentially what NLU tries to do, right? And NLP works with the syntax and the pre-processing, and then NLU works with the semantics, right? Now let's switch to machine learning. Now all of this is part of machine learning only, but in order for us to understand machine learning, it's important to understand how the world could be without machine learning, right? If you were to take a bunch of user utterances and then try to guess what the user is trying to say, you probably want to write a whole bunch of rules to understand, okay, if the word has some lookup action, if the sentence has some lookup action and it refers to an object like contracts and it refers to some parameters, user is probably talking about looking up contracts, right? But contracts may not be the only word user may use. User may use many other words to describe contracts. Agreements would be a way to describe contracts, right? So you code all of these rules in your application to understand, okay, if this is the case, if this is the case, if this is the case, then users trying to look up the contracts. And then that you will probably notice some exceptions to these rules. User may combine multiple objects in one sentence. So your rules-based code is not adequate to handle that. So you will code more rules. So one thing that is guaranteed to happen with rules-based programming is your rules is going to keep on growing. And at some point, your rules may conflict with each other, in which case you need to code exception rules and so on. So this makes your program very complex. And rules is something only an expert programmer can write, right? A non-expert programmer or a non-expert user cannot build these rules. So that makes the application really hard to build. Machine learning basically turns this paradigm on its head. Why do we have to write these rules? Is there a way for us to synthesize these rules automatically? So in that case, how do you synthesize the rules? So machine learning is basically an art of writing a program that takes training examples and then tries to automatically build these rules, right? So if you're trying to recognize an image, the training examples could be, okay, this image is a cat, this image is a dog, this image is some other animal, and so on. And the machine learning algorithm tries to understand the input and your labels and tries to make an association. Okay, I found these things, and the user said this is actually a cat, so I think these 4 things could mean cat. So it can still lead to ridiculous rules building. So that's why your training examples have to be adequate. Otherwise, garbage in, garbage out. So with this type of programming paradigm, it's easy for us to scale your rule set, right? By providing more and more training examples. So this is something a non-expert user can do, right? Training is something that a business analyst can do, and that makes it easier for you to build your app. And data is something that you're going to constantly keep getting, right? As more users interact with your system. And it may be even possible to automate this training to a degree. So your algorithm gets smarter and smarter. So that is machine learning. Now on to deep learning. Now, machine learning is good and powerful, but it doesn't keep on getting smarter as you add more data, which is what you want. Right? Beyond a point, the smartness of the algorithm saturates. So that's where deep learning comes in. So deep learning is in some ways an old wine in a new bottle. It used to be popular in the 90s. It's based on neural networks. So there are layers and layers of neural networks. Each layer processes information, sends it to the next layer, and so on and so forth, until the real output comes out. That's essentially how deep learning systems work. Deep learning has become popular now because back in the 90s, we didn't have the processing capabilities first of all, we didn't have access to all of this data that we have access to now. And on top of it, we didn't have the capability to process all of this big data. We didn't have the, computing power, etc., to do that. Now we have all of that. So deep learning algorithms have come back. Now, deep learning works better than machine learning because they can get smarter as you add more and more data, and we have access to all of that data now. And it also has some properties like transfer learning. It can learn things from one context and take that to the other context, right? So basically, you can build models that have been trained to understand the English language, and then you can do some fine-tuning of these models to understand how to read English contracts. And it also has the ability to self-select features. So as it traverses through the neural net, it can highlight or suppress features that are important or unimportant. So all of these properties make deep learning really interesting. And deep learning obviously is a lot more complex science than machine learning. So yeah, that's the difference between the two.
Our sponsor for this episode is Spot by NetApp. Spot provides a comprehensive suite of cloud ops tools that make it easy to deliver continuously optimized and reliable infrastructure at the lowest possible cost. Imagine automating your infrastructure to proactively meet the needs of your applications. Imagine leveraging the latest in machine learning and automation to scale your infrastructure using the most efficient mix of instances and pricing models, eliminating the risks of over-provisioning and expensive lock-in. From cost management to infrastructure automation and CD to running serverless Spark on Kubernetes, Spot ensures you maximize your cloud investment. The end result is simply more cloud at less cost. Discover how the most innovative companies, from cloud-native growth machines to forward-thinking enterprises, are automating, simplifying, and optimizing their cloud infrastructures with Spot by NetApp. Check them out at spot.io/SERadio, where you can find more information, request a demo, or give a try by starting a free trial.
So I've heard of Word2Vec and BERT, B-E-R-T, in this context. Could you elaborate on these?
Sure. So Word2Vec is basically a technique to transform words to numbers. So it's important to do that because we need a mathematical model to work with words. A computer needs a mathematical model to work with words. Once you have that mathematical model, you can start, performing word arithmetic, comparisons of words. One of the most celebrated examples here is Word2Vec models can be used to compare. Let's say if you said man to woman is same as king to, and then Word2Vec model can say king to queen. Or it can associate meanings like, or rather, it can understand that Sweden is more closer to Norway than more closer to US, right? So all of this is pretty much learned in an unsupervised manner. It can read pages and pages of text. Once it's transformed to some mathematical model, it can make all of these associations pretty much on its own without any human intervention. And people have built interesting models on top of this, are using this principle by embedding more and more contextual meanings, by taking words and mapping them to multiple vector forms. And using those models, you can do lots of interesting things. Examples of models that work this way are BERT and GPT-2 and GPT-3. People have built models that with GPT-3 that can read pages of text and practically answer questions on that based on that text like a human would with no additional training. So that makes it really interesting.
So it won't be in the scope of our conversation today to go deeper into BERT or Word2Vec, but it would be great if you can point our listeners to any reading material out there.
Yeah. So if you're a casual user or reader, you can Google your way to a lot of this information. But if you're a little bit more serious, there are YouTube Stanford lectures that you can listen to. Or if you want to do something more specialized, there are Coursera courses by Andrew Ng Very comprehensive machine learning and deep learning courses are offered there. There is Udemy courses. So you can do all of this. Or if you're really, really serious about, having a career in this space, you need to actually build some applications to, understand these technologies in more detail.
So we'll check with you, Venky, and put some of key links that you found useful in our show notes.
Absolutely.
Let's now talk a little bit about other B2B problems that could be solved with this infrastructure. Have you encountered any of these?
Yeah, so there are lots of problems we can solve with good NLP, NLU capabilities. So chatbots is one immediate application. We've talked about it at length. If you, in the world of contracts, there are a lot of interesting problems that you can solve in this domain. For example, so many times we receive different contracts by mail, your home warranty contracts, your Verizon contract. It's like 15 pages in size, and you never read through them because it's a lot of legal language. It'll be nice if somebody can summarize to you the 4 or 5 bullet points that you care about. Things like, what is my annual payment or monthly payment? What is my early termination penalty? And what if I move to a different city? What if I want to change my telephone number? That sort of thing, right? So being able to read a contract, provide critique on the contract, providing a summary of the contract is a useful problem to solve. Being able to have some kind of a best practice template and being able to semantically diff it would be another interesting problem to solve. Being able to read the contract and understanding the different risks in it would be another problem to solve, and so on. This is just the world of contracts. So if you may have used Zoom meetings, right? A Zoom meeting now has this live transcript, right? So the live transcript, not the live transcript, but rather the transcript of the meeting that you are in. So that's another NLP problem. And also auto summarization of your conference call would be another interesting problem, right? If you were on the call for 2 hours, what's the summary, right? So these are all various problems that are really interesting to look at. I think some companies are already beginning to solve them, but it hasn't become mainstream yet.
Let's switch gears a little bit and talk about the data. These bots and conversational interfaces that we have been talking about are very focused on the domain. So what about the data for training?
Yeah, so you definitely need domain-specific data for them to be meaningfully trained. You need to work with domain experts. So in the case of contracts, you probably need legal operations people, right? You probably need to hire lawyers to train and build these models. So it's going to be a combination of using their expertise, and also there is a lot of rich data out there on the internet. So if you just need public domain contracts, there are probably thousands of them, millions of them. So you can download from these data sets and use that as well. But you're also going to learn a lot from your customer data. But this is a sensitive subject because customers need to opt in and allow you to use that data. And our hope is that this industry is going to evolve somewhat like how the music industry evolved. When Napster came along and said, I'm going to publish all the music online, there was huge resistance in the industry to go in that direction. But 20 years later, pretty much all of the music is consumed online. So we think eventually customers will be more open to the thought of sharing that information for their own good and for the goodness of the entire community. So yeah, using a combination of homegrown, the public domain data as well as your customer data, you can build your models and make them smarter.
How does testing fit in?
Yeah, testing is a little tricky here because this is not conventional software where you've written requirements and then you've coded to those requirements and you can just test through the requirements. Because if you built a wizard-like screen in conventional software, unless there is a next button, you cannot click on it and go to the next screen. But this is a chatbot, so anybody can say anything at any point in time. So the testing is somewhat unconventional. You still need your regular automated unit testing and your regression testing and your regular functional testing and all the performance testing and all of that. But in addition, to ensure that what you've built is functionally complete and it makes sense for an end user, you need to put it through some kind of a crowdsource alpha testing. You need to engage users across different teams. If you have a sales team and a marketing team willing to participate in this testing, invite them, engage them, and get feedback from them. If you're targeting consumer audience, you can test it with a focus group to understand whether your application is working or not. So once you have a deployment of your app, then you have a lot of data from your customer usage, and from that you can get meaningful insights and understanding of how this is going to be used. So typically when you introduce some new feature, you want to run it through some kind of a trial process to ensure that this is going to work.
So you also said that once the product is being used by customers, that's additional feedback. Is that data also used for further training?
Yeah, absolutely. So here you probably need to declare or disclose to the customer that you're planning on doing that, and it's pretty much part of your software licensing agreement. But in some cases, customers may be okay with using certain data, may not be okay with using some data. So in that case, it becomes a little bit more complex. You need to then start anonymizing the data, masking important pieces of information, right, that are not significant for your model, because your model probably doesn't need to know that the value of a contract is $20,000. It probably cares about other aspects of the contract, right? So in that case, you can try and solve the problem that way. But some cases, customers may be extremely sensitive and say, I don't want you to touch my data at all. I want you to just use it for processing and nothing else. In that case, you pretty much have to honor what the customer is saying and not use the data for any other training.
In terms of training and testing and the whole life cycle, what about localization? So if you have, if you're done with English and you want to now move on to Spanish, what does that mean?
So this is a lot more complex topic because you need to start with your language models, right? So you need a language agnostic model, first of all. And you need to be able to, and if you've written all of these business speak layers, right, which you've probably written for English, you need to write them or rewrite them or adapt them for different languages. So that's a big complex piece of work. And then as you run through your bot and bot produces output, you need to tailor the output in the appropriate language. I think the localization, as in presenting the output in a particular language, that's probably the easier part of the problem. The harder parts of the problem are understanding what the user is doing NLU and NLP and NLU for your languages, and then doing all of the added layers, the domain-specific NL layers in the specific language. That's where the complexity is.
We did talk about the Q&A part and the dialogue orchestrator. What about actions? What are the additional integrations needed to perform actions? Maybe there's a integration with the notification service. Does that make sense? Is there something else that you need to build for that?
I mean, your actions are going to depend on what type of workflow it is. Your action could very well be, if they are asking for information on something or account information, you can very well dip into your CRM system and lift that information. Or your action could be like, if you're turning on a heater system, you need to externally interface with some Nest or some thermostat to turn that on. Or it could even be user asking, hey, send me reminder notifications about something that's happening in the system. So speaking of notifications, which seems like the essence of your question, yes, I think it may seem like mobile notifications and chatbot are somewhat orthogonal, but they have an opportunity to coexist and deliver a pretty good set of use cases. So in Max, we have integrated these things very closely. We send a combination of reminder notifications and just-in-time notifications, and then user can take follow-up actions on these notifications. For example, if you send an agreement for approval, you want to notify the user who needs to approve this agreement. And right there, as part of the notification, you provide the user the option to do follow-ups, and then the user can do follow-ups. And then when the user takes follow-up actions, it notifies the sender that, actions have been taken, the ball is on your court to do the next steps. So this helps us move workflows at the speed of the user, and not be like bound or shackled by technology. So chatbots play an important role in making all of this happen.
So we talked about languages, and now I'd like to ask you about voice. Did you integrate with voice?
So voice is a very complex topic. So Siri, Alexa, they work as two-way voice engines, right? They work like that primarily because they solve very simple problems, right? If you want to really build a good, solid B2B application with voice, what does it take? First, you need a voice recognition engine. Typically, you would simply buy these engines because there are a lot of good ones out there. But there are some unique complexities that you will have to handle, right? So in the world of B2B, if the customer says, pull up the Cisco agreements that are from last year, right? What Cisco are you talking about? Are you talking about CISCO, the networking company, or SYSCO, the food distribution company, right? In text, it's pretty clear which one it is. In voice, it's not clear, right? There is ambiguity in what is being spoken. So you probably need some dynamic dictionary integration with your input processing. And then when you come back with information, if you're pulling up a code, there are like 15 line items in a code. How do you render this in voice? If it's like visual, you can simply show it. User can scan it. It makes a lot of sense to the user. If it has to be rendered in voice, how do you render this in a manner that that helps the user consume all of these details easily? So in that case, you probably need to summarize the 2 or 3 things. You're missing information that user may care about, and also you may have to build state machines to render the output itself. All of this makes voice somewhat less useful, two-way voice somewhat less useful. But what may be more useful is one-way voice, right? You can use Siri, Alexa, like dictate, like interfaces, or even your built-in mobile phone dictation services to inject your input in voice, right? And then you can get back the output in text, right? That way, you don't have to type in your mobile, which may be complex to do with limited real estate and limited keyboard capabilities, but you are able to still effectively use it and retrieve the information that you are looking for. So that's how we thought about voice. It's more one-way voice than two-way voice. Yeah.
The last part of the platform section, would like to get a little bit of insight into deployment. What were the additional components you had to think of deploying, and did they change your basic framework in any way and your pipelines?
So when it comes to deployment, you still have the traditional software stack. You are running your microservices in a container, and you probably have a need for your cloud infrastructure, like your Redis and Mongo and or whatever database that you're using, et cetera, right? So you still need to solve all of the traditional deployment problems. So when it comes to deploying NL-related stuff, there is models, right? There may be a base model, and then there may be customer-specific models, and then even the base model may not be one thing. It may be a combination of things. You need tooling to deploy all of that effectively. And sometimes you may not sure that a particular model will function great. So you probably need to have infrastructure to do some kind of an A/B testing. So you deploy a newer version of a particular model, and you want to see how that behaves. So you want to study that before you roll it out to your general user base. So you need to probably have infrastructure to do that type of rollout. And in addition, there may be configurations and other things that you may want to deploy as well. So you need tooling and an infrastructure for all of this.
Let's switch gears and now talk about building the team. What is the makeup of a team that builds this app? What skill sets are needed? Perhaps you can talk about how you build a team. Was a build and buy decision done before or after? Some information about the team would be great.
Yeah. So build versus buy is never straightforward one or the other. It's usually almost always a hybrid in practically all projects that I've been part of. You buy things where you can realize quick time to value and there's not significant advantage in building, or the cost of building is very high. and you end up building a whole bunch of things that nobody has solved for you, right? So that's how I think about buy versus build. So it's usually a hybrid. So in terms of team skills, it's going to be a combination of data scientists and traditional software engineers and DevOps and user experience experts, traditional engineering managers, product managers, etc. Right, and then if you need to solve domain specific problems, right, you may have to hire domain specific experts, or you can contract their services. The case of contracts, you may want to consider adding legal personnel to your team, right? Because UX is a big part of this. People often underestimate how important UX is to this. UX is a very critical part of building a good virtual assistant, because you need to blend your traditional user interfaces with the chatbot interface. And unlike traditional interface where user is already pre-trained subconsciously to go look for things in a certain manner, there's no such thing for chatbot. So you need to figure out a way to educate the user without sounding too invasive. You cannot show like a very complex UI with hundreds of knobs for the user to learn about. You need to do that in a very subtle manner. So UX plays a big role in this. And then finally, like we had talked about earlier, when it comes to testing, you need to crowdsource the effort. You need to involve multiple people from different disciplines. So you need to consider them as well as part of the larger team that you're trying to build these things.
Yeah, thank you for answering the question about the UX design. That was going to be a specific area I drilled into further. A key example I have from my recent experience is just that if you don't do that, you probably will get up ending JSON somewhere in your chat. And that's a very basic thing you don't want to do. You certainly want to format your responses, if nothing else.
Absolutely. I think in addition, let's say you're serving user wants to order food in an airline, right? The choices of food that you have is more appropriately, delivered as a traditional user interface, as a card, right? That you can view, so the user can view the image of the food and then the price, the nutritional information, etc. Right? How do you deliver all of this in chatbot? So it has to be a combination of traditional user interface with the chatbot like stuff. So I mean, this problem is fairly well solved. But yeah, UX helps you build these things very creatively and deliver a superior user experience to the user. Yeah.
So one of our listeners would like to start a new company where conversational interface, or maybe just NLP, NLU, is at the heart of the experience. How would you advise them to get started?
So I would say start with your business problem and think about how best to deliver a solution to address your business problem. And then think about all of the interfaces that you need to deliver that value. And then think about how chatbots will enhance that user experience. Don't start with the notion that, hey, you need to build a chatbot company. That's not how you should think about it. Always start with the business problem. I think once you do that, you will have a clear understanding of how chatbot fits into the overall puzzle and enhances the overall value of your product. But once you do that and you understood what use cases to deliver and how to deliver these, then you can think about all of the things we just talked about early on in the segment, right? Where to place the UI, and what NL engines to choose. Then do you want to build or buy your dialogue orchestrator? Then how best to build your bot, etc. All of those considerations come into the picture.
Are there any open source technologies or commercial technologies that you think people should evaluate?
Yeah, there are tons. In fact, nobody writes everything from scratch in this domain, right? You typically leverage a lot of open source work that has been already done for you, and then you build on that. So if you're solving the traditional chatbot problem, there is Microsoft Lewis, there is IBM Watson, there is Google Dialogflow that you can start with. You probably want to augment that with your own proprietary algorithms and so on. And then if you're solving different kinds of NLP, general purpose NLP problems or contract language understanding, that type of thing, you can start with the language models that has been built for you, right? BERT and and a ULM fit and GPT-2 and GPT-3 and so on, and then see how you can adapt these to solve the specific problems that you are solving.
Thank you, Venky. So starting to wind down now, what other use cases or applications are you thinking about for the platform you've built beyond conversational UI?
Yeah, so I talked about conversational UI and alerting. In addition, it's a good, you can think of it as a search engine, right? How do you search on Google? You pretty much type things in natural language, right? And then it brings back information that you want. So it's a useful interface for a search engine. And then it can be a good document analysis tool. So there are different kinds of documentations that exist in our world. I talked a lot about contracts. So there are lots of different problems you can solve with contracts, like auto summarization, semantic similarity, and many other problems that we discussed early on. Yeah, those could be solved with Max-like technologies.
Is there anything we missed today that you would like to cover?
Nothing in particular. I think we pretty much covered everything exhaustively. I mean, I'm a humble little student in this space, and I have a lot to learn. If you got good, bright, productive ideas, and you want to reach out to me, I'll be happy to share whatever little I know, and happy to learn what you can offer me. And let's do that. Let's connect offline if you want to chat further.
And how can people contact you?
So I'll leave my email and other information with you, and then we can share this with our viewers. Thank you.
We'll put some contact information in the show notes.
Absolutely.
Thanks again, Venky. This is a great session. I hope our listeners learned from it just like I did. This is Kanchan Shringi for Software Engineering Radio. Thanks for listening.
Thank you very much. I really love the chat and hope to connect with our users and learn more from them. Thank you.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.